Hello, everyone. In this video, we will begin to introduce object-oriented thinking in Chapter 10. The focus of this chapter is on class design and to explore the differences between procedural programming and object-oriented programming. The preceding chapter introduced objects and classes. You learned how to define classes, create objects, and use objects. This book's approach is to teach problem solving and fundamental programming techniques before object-oriented programming. This chapter shows how procedural and object-oriented programming differ. You will see the benefits of object-oriented programming and learn to use it effectively. Our focus here is on class design. We will use several examples to illustrate the advantages of object-oriented approach. The examples involve designing new classes and using them in applications and introducing new classes in the Java API. Let's look at this concept, class abstraction and encapsulation. In Chapter 6, you learned about method abstraction and used it in stepwise refinement. Java provides many levels of abstraction. And the class abstraction separates class implementation from how the class is used. The creator of a class describes the functions of the class and lets the user know how the class can be used. The collection of public constructors, methods, and fields are accessible from outside the class, together with the description of how these methods are expected to behave serves as the class contract. So here's the class contract for the class. It serves as interface for the class. The detailed implementation of the class is encapsulated in the black box. The client uses the class through the contract. So the client knows what are the constructors, what are the methods, and what are the data fields that may be accessible. Class abstraction and encapsulation are two sides of the same coin. Many real-life examples illustrate the concept of class abstraction. Consider, for example, building a computer system. Your personal computer has many components: a CPU, memory, disk, motherboard, fan, and so on. Each component can be viewed as an object that has properties and methods. To get the components to work together, you need to know only how each component is used and how it interacts with the others. You don't need to know how the components work internally. The internal implementation is encapsulated and hidden from you. You can build a computer without knowing how a component is implemented. The computer system analogy precisely mirrors the object-oriented approach. Each component can be viewed as an object of the class for the component. For example, you might have a class that models all kinds of fans with properties such as fan size and speed, methods such as start and stop. A specific fan is an instance of this class with specific property values. Another example is the loan. We already used this computing loan already in chapter 2. So now we're going to design a class to model the loans. So you can create a loan object whenever you have a loan. So what we do here is to design this loan class. This is the class here. This is the loan, has the private data fields, annual interest rate, number of years, loan amount, loan date, and this is the date when the loan was created. So this are the constructors, two constructors, NOAA constructor, and this is the constructor with specified annual interest rate, number of years, and loan amount. And these are the get methods, and this are the set methods, and this is the get monthly payment, and this is get total payment. Now, without knowing the implementation, suppose you have this class available, you can use it because this is the interface. This is how you know about the class, how to use the class. So we're going to write a test program. This is the test program. So we're going to prompt the user for the loan information, annual interest rate, number of years, loan amount. Now we can create a loan using all this information here. So this is the information right here. So we create the information, the annual interest rate, number of years, loan amount. And now we can get the loan date and get the monthly payment and get the total payment. When you're learning writing programs, now you play two roles. You are the user and also you are the developer. You have to now implement this loan class. So this is the implementation. So we're going to implement it. This is the NOAA constructor. So I'm going to use this. Put some default value for the annual interest rate. So let's see, I'm going to have something like 3% for the annual interest rate. And the number of years is 10 years. And the loan amount is 10,000. So this will invoke the constructor, this constructor. In this constructor, so you're going to assign the annual interest rate. And this argument, annual interest rate, is assigned to this dot annual interest rate. For the loan date, you can now use new date. This is going to be the current, representing the current time. So, and here we have this date. It's right here. We did not import it here, so we have to use java.util.date. So this is the get method, get the annual interest rate. And so this set method, and this is the get monthly payment. So we use the formula in chapter 2 to compute the monthly payment. So this is, first we get the monthly interest rate. That's the annual interest rate divided by 1200. And now we're going to return monthly payment. This is the implementation. Now, this is the important pedagogic tip I want to share with you. Use the UML diagram for the loan class. First, to write a test program that uses loan class, even though you don't know how the loan class is implemented. This has 3 benefits. First, it demonstrates that developing a class and using a class are 2 separate tasks. Second, it enables you to skip the complex implementation of certain classes without interrupting the sequence of this book. For some of the complicated classes in the book, you don't have to dig into the detailed implementation. You can skip it, and later you can come back to restudy it, but it allows you to continue to move on to the next subject. Third, it is easier to learn how to implement a class if you are familiar with it by using the class. So you know what the class is about and how to use the class, and before you actually write a code to implement it. That's all for the start of this chapter. See you on the next video.